All right, it's the first time I tried this. I screwed it up. Hopefully this time I'm going to get it right for you here. So here we've got 36 divided by x squared minus 9 minus 3 equals 2x over x minus 3. We are being asked to solve this. Now, what we're going to want to do is we're going to want to clear the fractions. So to clear the fractions, to see what's needed, I'm going to factor this. This becomes x minus 3 over x plus 3 minus 3 equals 2x over x minus 3. And what I'm going to note that is if we multiply by this denominator, then x minus 3 and x plus 3 are going to cancel each other out. Turns out it's also going to cancel out the x minus 3 in this fraction here. It's going to basically make things so that there's no more fractions. And that's going to be a lot nicer to deal with. So let's do that then. We're going to multiply this side by x minus 3 times x plus 3. And multiply this side of the equation by x minus 3 times x plus 3. All right, so let's see what that does. First of all, first fraction becomes 36. X minus 3 times x plus 3 over x minus 3 times x plus 3. The x plus 3's will cancel on that one and on this one. Next, this becomes negative 3 times x minus 3 times x plus 3. Over here, this becomes 2x times x plus 3 times x minus 3 over x minus 3. And in this fraction, the x minus 3's are a common factor, so they'll cancel. So what we are left with is 36 minus 3, and multiply these two together, you have x squared minus 9 equals 2x times x plus 3. So 36 minus 3x squared plus 27 equals 2x squared plus 6x. Okay, I am going to select that. And let's crop it and then make the screen bigger. You're going to give us more writing room. Okay, so now what we want to do is get everything on one side, because when we've got x squareds floating around, we know we're going to go to the zero factor theorem. We're not going to just try to get x on one side, numbers on the other. We're going to go for the zero factor theorem. So let's subtract 2x squared from both sides and subtract 6x from both sides. Okay. All right. And so 36 plus 27 have to be added together. They give you 63 minus 5x squared and minus 6x equals 0. Or in other words, negative 6x squared minus, or next, doggone it. Sorry about this. Placed in order, you got negative 5x squared minus 6x plus 63 equals 0. Now, we first look to see if there's any common monomial factor we can pull out. We cannot. Okay? And so then the next step we're going to do is we are going to then factor this by multiplying these two. We're going to make it into 4 pieces. We got 5x squared negative plus 2x terms plus 63 equals 0. And the way we're going to get those 2x terms is we're going to multiply negative 5 times 63 is negative 315. We're going to look for two values that multiply to give negative 315 and add to give -6. Okay? Well, -315 and 1 multiply out to the right thing, but sure don't add to the right thing. Okay? How about, well, doesn't look like 2 works. 3 should work because these 3 digits add up to a product whose add up to a number whose multiple of 3. So let's see. I've got 3 times what though? 105 negative. Still way too negative. 4 won't work. -5 times 60, or -5 times 63, or 5 times -63 will work, but again, that adds up to -58. Okay, how about 7? 7 does work, and so we have got 7. 315 divided by 7 ends up being 45. So, but it still adds up to -38, still too big. Let's try 9. Well, 9 times what equals -315? Looks like 35. Again, still adds up to too big of a negative number. And let's try then 11. I'm avoiding the even numbers because those clearly won't work because this is odd. So 11 won't divide evenly in here. How about 13? 13 won't work here. How about 15? Well, 15 goes in -21. Okay, -21 times 15 equals -315. We add them together. Phew, that adds up to -6. Okay, so for all that, all we've done is -5x squared plus 15x minus 21x plus 63 equals 0. We've just re-expressed this up here so it can be broken into pieces and factored. This becomes -5x times x minus 3, and this becomes -21 times x minus 3. Because we have to watch for the sign here. It's a little bit complicated. -5 times +15 gives you, or -3 gives you +15. -21 times -3 gives you +63. So then we notice x minus 3 is a common factor. We pull it out. -5x minus 21. Okay, so this is how things factor out. And then we are clear to solve by factoring. So if this product equals 0, then either x minus 3 equals 0 or -5x minus 21 equals 0. This means x equals 3 or -5x equals +21, adding 21 to both sides. Divide both sides by -5, you've got x equals -21, over 5. So it looks like we get 2 possible solutions. But now we've got to go back in and check for extraneous solutions. When we've got fractions involved that have x's in them, we've got extraneous solutions as a possibility. So let's look back at the original problem. What happens when x equals 3? This fraction becomes undefined. So does this fraction. It just doesn't work as a problem. Substituting 3 makes a denominator 0, and the world blows up. So x equals 3 isn't a solution. Substitute in -21/5, it's going to get messier than it already is, but that is in fact going to work. So -21/5 is the answer that checks and isn't extraneous. A lot of work to get to it, but that is basically what's involved. So the steps are First of all, multiplying both sides of this equation by the denominator to clear out the fractions. Then we go through the multiplication and set everything equal to 0. Why we do that is because there were x squareds in the mix. And then we solve that by factoring, which in this case ended up being quite complicated.